Hi and welcome. This project that I'm working on this time is sort of one of need. The height gauge I've got here came with a scriber, but what it didn't come with is an adapter to hold indicators in there. So I built one a long time ago as one of my early projects to hold a drop indicator, like one of these. And that one was quite successful, but I really would like to also be able to hold a normal dial indicator. And the problem is that they're sort of secretive about the Dovetail, and I found one site on the internet that had the dimensions of the Dovetail using 0.79 millimeter or 0.031 inch pins as the measurement. I had to go back and use some geometry to calculate the actual dimensions of the Dovetail. The site was one in New York that repairs indicators. And anyways, so I'm going to make an indicator holder that fits in the height gauge and also one for my Squaremaster. As long as I'm at it, I'll make a couple. Why not? So in case you're curious, so most indicators have dovetails on them, and there is some sort of standard associated with them. And the way you go about measuring them, according to the repair site, and the only information they actually give, is across 2.79 millimeter or 0.031 inch pins, which I had to buy because I have a set but it only has one. So anyways, I went and bought a couple more, and you measure across them and it's supposed to be 0.251 inch, which they seem to vary a little bit. This one's like 0.255 and this one's like 0.250. So one's a Brown Sharp, the other here is a Michutoyo. And any case, like I said, I used a little bit of algebra and trigonometry to calculate the actual dimensions, and I will post this sheet for you because I'm probably not the only one interested in this. The holder I'm going to build is fairly simple, but the way I'm going to cut out this Dovetail is a little bit different, something I've never done before. So hopefully we'll all find it interesting and useful. Quick note worth mentioning is the Michutoyo came with this, I don't know, this is like 3/8 diameter to Dovetail. This is what I'm going to be trying to duplicate. And although they vary in size a little bit, it's snug on the Michutoyo and a little bit looser on the Brown & Sharp, but will still work. So if I emulate this guy, I should be good. So setting up here, we're going to make the punch that we're going to try and cut out these dovetails, since I could order a small dovetail cutter, but it would cost $140 each, and I have to buy a minimum quantity of 5, so that's not happening. So instead, we're going to make this dovetail cutter that we're going to hope to use the mill and just broach it out. Over here we have the multi-axis vise, and I had to trim it in. So we've got it trimmed in now to be in line with the mill itself. I've also got to do up-down, which I haven't done yet. And to tram this guy in, since it's in a nod configuration where the center of rotation's back here, and this whole thing was forward, that meant every time I took the part down here, it would rise really fast, and then down here, it would be positive really slow. So all I do is go to here, set a 0, go here, back to the other end. It would the dial would go up. I tap it back so the dial was down here, go back again, reset my 0 until there was no change from side to side. And it took quite a few iterations, but we're there. So next up, I've got to set the 0 here on the vertical with this rotation adjustment, but actually we want a -2 degrees because I'm going to put a 2-degree draft in this. I'd put more, but this part's already too slim and I'm really concerned it's going to break. First up, we're going to face this part and set our 0 for our depth, because that'll give the edge of the mill. And then we're going to make a flat spot that goes all the way back, and the flat spot is going to be 100 thousandths down, and it will help us locate this part again if we need to while we're working on it. It'll also help us locate the flat side when we are going to do the punching itself, because we need to be able to orient the punch correctly, or the broach. I guess it's really officially a broach because that's what we're trying to do here. pass. I realize at this point it's hard to see, but I've dipped the nose down 2 degrees, and that's going to let us cut that relief that we need for this brooch. And so now what we need to do is we need to go down a total of 151 thousandths and go in 400 thousandths. The way I found my zeros, I got the very sharp edge of this just over the edge of this part, stuck some paper in there till it caught, and then compensated for the paper, which is 3.1 thousandths measured by the mic. So we're 75 thousandths down, that's where we left off, and so we need to go another 76 thousandths. Going in a total of 400,000. We gotta be careful, it gets progressively bigger bite as it goes deeper. Alright, that was the last pass at final depth on this side. So we went in 400 thousandths, there's a 2 degree taper going this way, making this part higher than the back. And now we're gonna rotate the indexing wheel on this 120 degrees because we're going to make a 3-sided object, so a third of 360 is 120, and we're going to do it all over again. So as this part gets thinner and more delicate, I'm going to have to take lighter and lighter passes. So we're going to start with a 10 thousandths pass and see how that goes, 400 thousandths in, and we'll see how that works out. First pass of many, and I'll bring you back. Last pass we're going to do in 2 passes. Last 2 passes we're going to do 5 thousandths a pass because it's pretty sensitive at this point in time. And we are done. Boy, is that a tiny little thing. Look at how delicate that is. Holy cow. I do not know how this is going to possibly work. Jeez. Well, we're going to give it a shot. This is just an experiment. I accidentally screwed up and went a little bit too deep on this one. Everything was perfect until now, and I had to blow at the very end. So, next up we take this guy out of here and we try and harden it and then go for maximum toughness. So we'll harden it and then we'll temper it to maximum toughness. Well, we're going to try and heat treat this guy. So many things can go wrong. I have an oven, but one part heating the entire oven up I think is a bit extreme, so we're going to try it the hard way and just use MAP gas. And quench it in oil. Now this guy is sitting at its maximum hardness. You can hear how it rings. Now I don't know how good a job I did of heat treating that, because I obviously didn't hold it for a half an hour. This is a very thin part. Anyways, we're going to give it a shot. So next up, we're going to try and heat this guy until and 800 would be, well, just after blue. So we're gonna shoot for blue and go a little bit past. Let's see. You know, maybe I can do it this way. It'll make it easier to see. Oh, there's blue. That was quick. Oh, there we go. That was really quick. It's such a thin part. And back into the quench. Here's the finished tool, but it's so frickin' delicate. I have no idea whether this is going to work even a little bit. I'm kind of nervous about the whole thing. It seems like it's just going to snap. I mean, the force mostly is axially, not radial. But since I'm only going to be cutting on one corner at a time, there is some radial force trying to bend it like that. It sounds like it's not quite as ringy as it was before, but I don't know if I softened or toughened it adequately. I guess time will tell. Well, I was taking bites a couple thousandths at a time. You can see it just bent the part. So I did make it tougher because it didn't shatter, but the end result is still not strong enough to do it, and it took the corners right off. So they need to be harder, but if they were harder, they're brittle and they would have broken. You could see I just barely put a dent in the end of this. So, got to find another solution. Although the broaching idea was a total fail, it was an interesting experiment and I did learn some things. Also, my hand is not terribly steady when sharpening, so that didn't help the corners out at all. Trying to keep it vertical on a sharpening stone or even at 2 degrees, I could feel the corners catch every once in a while and it just rounded them off instantly. And that's my fault. That might be part of it, but this is just too flimsy to scoop out the amount of material that needs to be removed. So we're going to go to a second approach, and what I've done here is I've taken the part and I've rotated it 30 degrees so that the 60-degree angle is horizontal. And so we're going to take these pieces and pop them in the mill at the 60-degree angle, or 30 degree off of horizontal, and we're going to use a slitting saw and slit in, flip it around 180, slit in for the full depth, which I've used my CAD program so I didn't have to deal with all the trigonometry, so I know how far to go from the corner, and I know how far in to go as well, 73 thousandths. I will use an end mill to take out the center, and all I need to do is take a file just to clean it up. So hopefully that'll work right, since my last attempt was a failure, but entertaining. So that's where we're at, so let's head over to the mill and give it a shot. You saw the drawing, here's the setup. I've set the angle with this angle setting device and clamped the part against the fixed jaw. I've added an extension block to stick out past the end of this angle block. It's an adjustable angle setting block. Then what I did was I set the saw blade. I found out where the top edge met the top edge of this part. I went down the prerequisite 80 thousandths, and I'm going to go in about 80 thousandths. I think it's 70 something thousandths with the slitting saw. So we'll see how well this works. So we're going to take a bunch of passes down the middle to remove all the extra material. Total of 65 thousandths depth. This leaves me with some handwork to do with a file. Hopefully I can do it since my hand-eye coordination sucks, but we'll give it a shot, see what happens. Drilling the relief hole. Last step, saw it in half right down here to meet with the relief. Alright, so we have the part mounted in the vise. We have the vise clamped to the angle bracket with a bar going across the jaw. And now I'm checking to make sure the blade is centered appropriately, which it looks like it is. Let's take a closer look here. And now all we have left to do is cut. And we're through. And we just need to deburr it and put it all together. So we're just going to make a couple of thumb screws real quick. First we're going to face this off, then we're going to turn down a section about a 1/2 inch length to 0.3 inch diameter, leaving the final part 0.375, which we will knurl. We're going to tap and thread, and then we're going to part. I don't like their proportions, so I'm going to reduce the shank diameter a little bit. I mean, this would fit perfectly, but I don't think it looks quite right, so I'm going to take a little bit of material off. So there's a shot of the finished knurling. So now I'm going to part this guy off, put some Loctite on a screw, put it in here, and then cut off the screw to length. Next up, Loctite the threads, insert them into the knob, give them a good tighten, and I'll clean off the excess here. And now I need to remove the end of this, put it through here, and grind it to length. I'll be right back. Alright, here we are with the final assembly. Just take the thumb screw I made and pop it in. And the dovetails are not perfect. I don't have a triangular file that's sharp, that the serrations go all the way to the corner, so they're a bit rounded, but the angle's right and it grabs well, so it works fine. And you just pop this in your height gauge and pop in the indicator, snug it down, and you're good to go. I will be posting the dimensions for the dovetails in case you're interested in making your own. They're kind of hard to find and they're part of a standard, so they want to charge for them. I also include the pin gauge measurements using these 0.79 millimeter pins if you're interested to find out how they qualify the male portion of the dovetail. So I've got that information too, and I'll have it all ready for you in case you're interested. I hope you find it useful. Thanks for watching. Hope to see you next time.